Welcome to your deep dive. Ever wish you could just download a new skill, like instantly becoming a master chef or a coding whiz?
Or a podcast host.
Hey, now don't give the AI any ideas.
You know it's coming for us eventually.
Okay, true. But until then, we're diving into the mind-blowing idea of a single machine learning system that could learn anything.
Anything.
Yeah, you heard that right. No more separate AI for playing games versus composing music or even hosting podcasts. Just pure adaptable intelligence.
Okay, now that is a fascinating idea. So where do we even begin to unpack something like that?
Well, we're starting with a technical report by Jurgen Schmidhuber. He's a real heavyweight in the AI world. And the report, it's called One Big Net for Everything.
One big net for everything.
Catchy, right?
I've heard of worse titles.
Okay, fair enough. But the best part is it's about this system he calls One.
One.
Yeah, One.
Okay. I'm intrigued. So tell me more about this one.
Well, Schmidhuber's vision is pretty ambitious, to say the least. He's proposing a single adaptable neural network, kind of like a brain, but for AI.
Like a digital brain. I like it.
Right. And this digital brain, it could theoretically tackle A and Y task you throw at it. Writing poetry, composing symphonies.
Hosting podcasts.
Okay, we get it.
Yeah.
But seriously, we're talking about a system that's not limited to just one type of learning.
So it's not like those AI systems we see today that are hyper-specialized in one specific area.
Exactly. It's not just about, say, analyzing data or playing chess.
It can do it all.
Well, in theory, at least. But here's the kicker. One remembers everything it learns.
Wait, so no more AI amnesia.
Exactly. No more AI amnesia.
That's huge because it means one is constantly building on its experiences, becoming more knowledgeable and efficient over time,
Kind of like how we humans ideally learn from our mistakes and triumphs.
ideally.
Okay, point taken. But One takes this whole learning thing a step further. It uses some really clever tricks.
Like what?
Well, for instance, it can receive specific, what Schmidhuber calls goal inputs.
Goal inputs.
Yeah, think of them like instructions. They tell One what to focus on.
So it's like saying, hey, one, compose me a symphony in the style of Beethoven, but with a touch of jazz.
Now, that's a tall order, even for Beethoven.
You're telling me.
But you get the idea. It's about giving one direction, a specific goal to strive for.
Right, and like any good student, or maybe a slightly overachieving AI, it needs feedback to know how it's doing.
And that's where rewards come in.
Rewards.
Yeah, positive reinforcement for a job well done, or maybe a gentle digital nudge in the right direction if things go off-key.
So positive points for capturing that Beethoven-esque grandeur, negative points for accidentally summoning a disco beat in the middle of the symphony.
You got it.
Okay, I'm starting to see how this all fits together. This combination of goal-directed learning and feedback, it's crucial.
Absolutely. It mirrors how we learn as humans. We set goals, we experiment, and we learn from the consequences.
But one takes it to a whole new level.
Okay, get ready for your mind to be blown, because One also learns by predicting what will happen next. It's like how we can often anticipate what someone might say in a conversation based on their tone or previous words.
We've all been there.
Right. But One takes this to the extreme.
So it's not just about passively like trying to guess the next word in a sentence.
It's about actively seeking to understand the underlying patterns and rules of the world.
It's like one is constantly asking, why does that happen?
Yeah.
And what's going to happen next?
Exactly. And all that knowledge, all those patterns and connections, they become compressed and integrated into one's understanding of the world.
It's like one is constantly building this incredibly detailed model of how things work.
Okay, so we've got this AI that's constantly learning, predicting, and refining its understanding of the world, but how does it actually connect all this knowledge together? That's where things get really interesting with this idea of compressing all those learned skills.
Compressing all previously learned skills into one? It almost sounds like one is summarizing its experiences.
That's a great way to think about it. Schmidhuber connects this idea to something called algorithmic information theory.
Algorithmic information theory.
Yeah, it's a mouthful, I know.
But it's a fascinating concept, though, right?
Oh, absolutely. So imagine One has learned a lot about how objects move in the world, even if it's just from watching videos. Now, let's say we ask it to control a robot arm to manipulate those same objects.
So even though the tasks seem different, watching versus doing, there's this underlying connection that one can tap into.
Precisely. It's like having an aha moment, but for AI. By compressing and storing its experiences, one is essentially discovering hidden connections between seemingly unrelated skills. Instead of needing a whole new set of data for each new task, one can potentially learn much faster by transferring knowledge from previous experiences. That's a game changer, right?
Absolutely. It challenges our whole understanding of how AI can learn and adapt.
It's like instead of being a one-trick pony, one is becoming this versatile, multi-talented machine learning maestro.
And here's something else that surprised me. Schmidhuber actually says that one doesn't need to be perfect at predicting things for this to work.
Wait, really? I thought accurate predictions were like the holy grail of AI.
It's a common misconception. Perfect prediction, especially in the messy real world, is incredibly difficult. But the key takeaway here is that one's ability to learn to control things, to actually solve problems, doesn't depend on always predicting the future accurately.
So it's like saying, hey, it's fine if you don't always know what's going to happen next. What matters is that you can learn to adapt and make the best of it.
Precisely. It's about developing robust and adaptable intelligence, not a crystal ball. Think of it this way. One might have subroutines dedicated to predicting, say, the weather or the stock market. Those predictions could be helpful for certain tasks. But the real magic is that one's ability to learn to do things like driving a car or writing code doesn't hinge on those predictions always being spot on.
Okay, that makes sense. It's like even if I can't predict exactly what traffic will be like on my way to work, I can still learn the best route and adapt to unexpected detours.
Exactly. And this is a fundamental shift in how we think about AI. It's not just about creating systems that can analyze data and make predictions. It's about building systems that can interact with the world, learn from their experiences, and adapt to new situations.
This makes me think about how we often approach AI with this very narrow focus. Like we want an AI that can write a screenplay, but not necessarily one that can understand the emotions that make a good story resonate with an audience.
It's a bit like trying to teach someone to paint by only showing them pictures of famous artworks. They might be able to mimic the techniques to some extent, but they won't truly grasp the nuances of color composition and emotion that make a painting truly captivating.
And that's what's so fascinating about one. It's not just about replicating human skills in isolated domains. It's about developing a more holistic, adaptable intelligence.
Right. It's about moving beyond specialized algorithms towards a more general-purpose intelligence that can learn and adapt to whatever challenges it encounters.
Now, we've talked about how one learns and predicts, but what about memory? You mentioned earlier that it remembers everything. Are we talking about a digital hoarder situation here with one clinging to every bit of data it's ever encountered?
Well, Schmidhuber suggests that ideally, one should store its entire history of interactions, every input, every action, every reward signal, every success, every blunder.
Everything. Wow, that's a lot of data. Even for a super AI, wouldn't that be overwhelming? Like trying to find a specific grain of sand on a beach.
It's a valid concern, but the idea is that one wouldn't just be passively storing this data, it would be actively compressing and organizing it, much like our brains do when consolidating memories during sleep.
So it's like one having these intensely productive dream sessions where it sifts through all its experiences, finding patterns, making connections, maybe even coming up with completely new ideas.
Exactly. And that's where the concept of compressing all previously learned skills into one comes into play. It's not just about remembering, it's about consolidating and integrating that knowledge to make it more useful and accessible. Think of it like this. Imagine you're learning a new language.
Okay, I'm game.
At first, you're memorizing vocabulary and grammar rules. But as you progress, you start to see the connections between words, the patterns in sentence structure. You're no longer just memorizing, you're understanding. And that understanding allows you to form your own sentences to express yourself in new and creative ways.
So it's like one is constantly building its own internal language of knowledge, a way to represent and connect everything it's learned.
Precisely. And this compressed representation of knowledge becomes incredibly powerful because it allows one to transfer knowledge between seemingly unrelated domains. It's like learning to ride a bike can actually help you become a better surfer, even though the activities seem completely different.
That's wild. So how does one actually do this compressing? Is it like zipping up files on a computer?
It's a fascinating process that involves constantly refining its internal representations based on new experiences and feedback. Imagine one is learning to play a complex video game. It might start by focusing on basic actions like moving and jumping, but as it gets better, it starts to develop higher-level strategies, understanding how different actions can be combined to achieve specific goals.
So it's like going from button mashing to developing actual skills and strategies.
Exactly. And as one masters the game, it can compress all that knowledge, those successful strategies and decision-making processes into a more efficient and adaptable form. And here's the kicker. This compressed knowledge can then be applied to other tasks, even those it sees completely unrelated to playing video games.
Okay, so we've got one, this incredible prediction machine with a massive memory, constantly compressing and connecting knowledge. But let's get practical for a second. How does one actually go about learning a brand new skill, especially when there's no teacher guiding the process? Like if we were to drop one into a completely new situation, something it's never encountered before, how would it even begin to learn? Let's say we challenge one to learn how to, I don't know, navigate a complex obstacle course. We're talking ropes, swinging pendulums, maybe even a foam pit or two.
The kind of thing you'd see on those extreme obstacle course shows.
Exactly. But here's the catch. No instructions, no demonstrations, just one and its sensors trying to make sense of this wild obstacle course.
Talk about a challenge. So how does one even begin to tackle something so completely new?
Well, that's where things get really interesting. This is where Schmidhuber introduces this fascinating concept of using what he calls copies of one.
Copies. Is one cloning itself now? Are we about to have a whole army of ones running around?
Not exactly. Think of it more like creating a separate instance of one, a copy with the same underlying architecture and knowledge, but with the freedom to experiment and learn independently.
So it's like one's protege, eager to prove itself in this obstacle course challenge.
Exactly. And here's the really clever part. The protege isn't just blindly stumbling through the course.
It's using its instincts, trusting its gut.
Well, not exactly instincts. It's leveraging one's accumulated knowledge to guide its actions.
So even though it's never seen an obstacle course before, it can draw on one's understanding of, say, physics, balance, spatial reasoning.
Maybe even a little bit of that baking show wisdom about structural integrity we talked about earlier.
You never know when that might come in handy.
Right. But okay, so the protege is out there learning by trial and error, probably taking a few tumbles along the way.
Oh, I'm sure there are some epic wipeouts.
Definitely. But how does it actually know what's working and what's not?
Remember those reward signals we discussed earlier?
Like positive reinforcement for a job well done.
Exactly. They're crucial here. Every successful maneuver, every obstacle overcome, it results in a positive reward for the protege.
And conversely, every stumble, every collision.
Negative signal.
It's like having a coach who's cheering for the wins and offering constructive criticism after the wipeouts.
Precisely. And over time, through this process of trial and error, reward and adjustment, the protege starts to get the hang of it.
It's learning.
Adapting.
And eventually navigating the obstacle course with increasing skill.
All thanks to that compressed knowledge passed down from one.
It's amazing to think that all of this is happening without any explicit programming.
No step-by-step instructions.
It's like watching someone learn a new sport or skill simply by observing, experimenting, and adapting.
It's a powerful testament to the potential of this approach to AI.
Absolutely. By creating systems that can learn and adapt in this way, we're opening the door to AI that can tackle a much wider range of challenges.
Even those we can't anticipate or program for explicitly.
It's like we're breaking free from the limits of our own imaginations when it comes to AI.
And that's both exciting and a little bit daunting, don't you think?
Oh, absolutely. This whole concept of one, it's mind-blowing. It's like a glimpse into a future where AI isn't just about specialized algorithms, but about adaptable, ever-evolving intelligence.
Lifelong learners, just like us.
Exactly. It makes you think about the limits of what AI might be capable of achieving.
And how we might design these systems to be powerful, but also beneficial partners in tackling the complex challenges we face.
It's a lot to ponder, but one thing's for sure. The future of AI is anything but predictable. And that, I think, is pretty darn exciting. Thanks for joining us on this deep dive into the world of one. We'll be back next time with another fascinating glimpse into the cutting edge of AI and what it means for our future.